Good morning, everybody. Thank you for joining me for this center of our math center this morning. Today we are going to be discussing our learning target, and our learning target for today is students will be able to add fractions with like denominators. So in our previous lessons recently, we've been talking about some of our other vocabulary words regarding fractions, like our numerator, which is our top number on our number line above our fraction line, and the denominator, which is the bottom number below our fraction line. We've also discussed things like equivalency, knowing that a 1 can be, 2 halves can equal a 1. We've also discussed things like simplifying, knowing things like 3/6 can also be written down in a simpler form as 1/2. So we've discussed all these things in recent days. Now we're going to go ahead and we're going to talk about adding fractions with like denominators. So today for our first question, we'll do 1/4 plus 2/4. 1/4 plus 2/4, pardon me. So we can go ahead and we can look at our fraction tiles and utilize those. So here we have 1/4 plus 2/4. So right away, it's pretty easy to go ahead and count our tiles. 1, 2, 3/4. We can also go ahead and we can write that down here. Can see here that we have a similar denominator, and we're going to go ahead and that's going to transfer over. And from there we know our base 10, and we can do 1 plus 2 equals 3/4. So 1/4 plus 2/4 equals 3/4. And we can look for our greatest common factors and make sure that we have simplified this problem all the way. So we can make factor trees off of our numbers. For 3, start with 1 times 3. 2 doesn't go in, so that's all we have. For 4, we have 1 and 4. We also have 2 and 2. 3 doesn't go in, so we know that that's as far as we can go. And we can see that we have a 1 is our only greatest common factor. So we do know that 3/4 is broken down as far as it can go. For our next problem, we can go ahead and we can use a different strategy. This time we'll work in eighths, and we will add 1/8, pardon that 8, it's a little crazy, plus 3/8. And here we can utilize our number line. We're starting, and we've used our number line is representing from 0 to 1, 1 being 8/8 because that is equivalent. And we can go ahead and we can start our math problem by marking our 1/8, and then we can count 1, 2, 3/8 and make the jump over to 4/8. We can also look at this on a circular model that we have it set up over here. Use a different color so we can see. So we have 1/8 plus 1, 2, 3/8. And here we can visualize it a little easier. We can see that that looks to be about half the pizza. So we probably know that this needs to be simplified further. So we're going to go ahead and find our greatest common factors, and we are going to use our factor trees. So we'll start with our 4. We'll come down here, 1 and 4, 2 and 2. 3 doesn't go in, so we know we have everything. 8, come down here, we do a 1 and an 8. A 2 and a 4. 3 does not go in. 4 goes back into 2, but we have that already, so we know we have all of our factors. So we can look at what do we all have in common. It looks like our greatest common factor happens to be a 4. So we're going to go ahead and we're going to divide 4/8 by 4 over 4. 4 divided by 4 we know is 1. 8 divided by 4 is 2. So our simplified number is 1/2 of our pizza. So from there, we're going to go ahead and we're going to give ourselves a little space here, and we're going to work on a word problem. Now, a fun way to work on this is to discuss some pizza. We all love pizza, right? So we can talk about our friend Daisy here and her pizza party. So our question is, Daisy had leftover pizza from her party. She had 3/12 cheese pizza and 7/12 pepperoni pizza left over. How much pizza does Daisy have left? And we always simplify when needed. So we can go ahead and take our information. She had 3/12 cheese pizza plus 7/12 pepperoni. Here we can utilize another circle model. So we can go ahead and we can do something simple as just go ahead and take 3/12 plus 1, 2, 3, 4, 5, 6, 7. And we can do it different ways. We can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 twelfths. We can also do it over here by bringing our denominator down because they're similar denominators, and we know our base 10, so 3 plus 7 equals 10 twelfths. And we can see if we go ahead and set this on the whole, kind of a rough estimate of how large we're getting. And last time we had half a pizza eaten, so we'll see how much pizza's left over from Daisy's party. These silly little things here. So as we can see, it's much more than half. So we will have to look at 10 twelfths, and we should go ahead and use our greatest common factor to see if this will simplify any further. So let's go ahead and start here with our 10, and we'll go 1 and 10, 2 and 5, 3 doesn't go in, 4 doesn't go in, 5 goes into 10 2 times, but we have that, so we're good. We'll bring our 12 over here. We have a 1 and a 12. We have a 2 and a 6. We have 3 and 4. 5 does not go into 12. 6 goes into 12 2 times, and we have that. So here we can go ahead and we can see that our greatest common factor is 2. So we're going to bring that over here, and we're going to divide this by 2 over 2. 10 divided by 2 is 5. 12 divided by 2 is 6. And if we want to double check our work, we can make sure in our factor tree, 1 and 5, nothing else goes in there. 6, we have a 1 and a 6, and a 2 and a 3. And then nothing else goes into that. And we can see that 1 is our greatest common factor, meaning that that is our simplified problem. If there's any other questions, please let me know. We're going to also work on this on our IXL as well as on our dice game. And we want to make sure we're sticking to our learning target that students will be able to add fractions with like denominators.